Morning girls. So today I'm hoping that we can take on DeMoivres theorem. Okay, so it's all about the polar form. So you must make sure that you're 100% a-okay with getting things into polar form. Okay, so remember polar form is we're getting into the r cos theta plus a sine theta. Okay, so your modulus and your arguments. So you need to be a-okay with this part before we can do DeMoivres theorem. Okay, so the first part is, if not already given, to get it in to the polar form. So for example, if we're given a complex number like so, 1 plus a. Now the difference here is, and the reason we're going to use DeMoivres theorem, is that our complex number now has a power. So everything's to the power of 10 here. So that means we need DeMoivres theorem. So we've got 1 plus a all to the power of 10. So first step is do what we've been doing and just take 1 plus a and put it into polar form. Okay, so this is the worksheet I gave you last week, so you should have this hopefully. So just take 1 plus a, forget about the 10 for now, 1 plus a, put it into polar form. So you can see, finding the modulus, so 1 and 1a, so 1 squared plus 1 squared equals 2, so I've got square root 2. From my diagram, finding the argument, so I've got my opposite, my adjacent, so I'm using tan of theta equals 1 over 1. Okay, now, where did the pi 4 come from? So this is where you need this page beside you, and you're going to need this beside you throughout the question. So tan of 1 is pi over 4. Okay, so remember we need it in radians. So tan of 1 is pi over 4. So this is where I've got this. So then we've gone through all that before. So now it's a matter of putting it into a polar form. So my modulus is root 2. My arguments is pi over 4. Okay, done. Now we get to apply DeMoivres theorem. So you can see up here I've got it highlighted in green. So it's very similar to the polar form, it's just you'll notice we've got the power. Okay, so we've got a complex number, so z to the power of n. We're going to say modulus to the power of n. Then because we usually add our arguments, we put in our n here, so they don't go to the power, they go in as a multiplier. So we've got n multiplied by theta, n multiplied by theta. Now, page 20 of the logbooks, you'll get that. So that's DeMoivres theorem. It's polar form with powers, and it's just knowing where the powers go. Okay, so you get a power of the modulus, yep, and then you put it in as a multiplier to your arguments. So then taking our example here, so we've got most of the work done, got it in polar form. So then we're going to put it into DeMoivres theorem. So you can see I've wrote out the general DeMoivres theorem here. So then I've got root 2 to the power of 10. Now just remind you, the 10's coming from the question. Okay, so root 2 to the power of 10, then cos theta, but remember you're putting in your n as a multiplier, so my power, so now it's then 10 multiplied by pi over 4 plus a sine 10 multiplied by pi over 4. So it's just filling out that formula then with the information you have. Then use your calculator. Root 2 to the power of 10 is 32. 10 multiplied by pi over 4 is 5 pi over 2. And same here, 5 pi over 2. So at this stage we've applied DeMoivres theorem. So now it's just a matter of tidying it up as much as we can. So cos 5 over 2 and sine 5 over 2. So what you must do is look it up in your tables. So again, this page should be open beside you at all time. So even though it's 5 pi over 2, 5 pi over 2, you look for the closest thing, which is our pi over 2. Okay, so this is where I can go to here, because we haven't got a 5 pi over 2, but we've got pi over 2. So I'm looking for cos of pi over 2. So pi over 2 cos, my value is 0 in degrees, so throw it in 0. Sine of pi over 2, so sine pi over 2 is 1, so I've replaced my sine of pi over 2 with 1. Then 32 is still there, we've got brackets, so we're multiplying, so 32 times 0 is 0, 32 times 1a is 32a. And that's our answer then. That's DeMoivres theorem applied. Okay, so just to remind you that this bit here, if it doesn't come up exactly as it is in the table, you go for the closest one. Okay, so if for example you got 3 pi over 4, we haven't got 3 pi over 4, but we've got pi over 4, so you'd go with this column here. Okay, so that's going through that example there. Now, I'm going to make another video explaining another example. I'll go through that, and then you can try the questions I've assigned for today.